Ooh. Hello, ROS developers. Welcome to a new ROS developers live class. I was here thinking about deep things of life, about the important things of life. But now I check that it's time that we start our ROS developers live class of today. And I'm super happy to be here today. And we are going to talk again about training robots with reinforcement learning algorithms. Today, we are going to talk about how to train different robots on the same task. So they will learn the same task, but we are going to use the same reinforcement learning training structure. So we are going to try to avoid having to create the whole training structure for one robot and then for another robot. So we are going to reuse as much as possible. And for this, we are going to use, of course, some algorithms of the OpenAI. And we are going to use the package OpenAI ROS. Remember that we have a chat here besides the window, this video, and you can post there some questions in case that you get lost during the class, because as you know, in this live class, you are going to practice with me. So whatever I do on the screen, you have to do it on your own right now, following the instructions, okay? And how is that possible? Well, because we are going to use the ROS Development Studio that you probably know, and it's a web platform where we can program robots with ROS without having to install anything. So you will get there. I'm going to provide you the address. Well, actually, it's a link with all the information. So you're going to get into that platform and get the project with the notebook, simulations, and code. And you are going to follow my instructions and do at the same time, okay? So in order to do that, you need to have an account, a free account at the ROS Development Studio. I hope that you already have. If not, just go rush and go there and create your own account. And yeah, so that's it. You only need that. And of course, you need to have the link. So what I'm going to do is to share a link of the ROS project that I have created for this class that contains that, what I mentioned, the notebook, simulations, and code. And I'm going to share this link with you. You will click there, and automatically a copy of that will be copied into your account at the ROS Development Studio. And then from that point, we can start working, okay? Remember, we have the chat on the side, and you can ask me questions there in case that you get lost or don't understand what we are doing, some of the steps. I'm assuming that you have already some familiarity with ROS, so this is not a basic class, but I will try to go as slow as possible and clarifying the points. Okay, let's go to the point. Then, if there is no questions there in the chat, no people saying it's working, yeah, okay, yes. Hello, Linda, Brian, Hubert, Cheryl, Danny Cash, and a name that I cannot pronounce because I think it's in Russian, I think. So sorry for that. And well, anyway, let's go. So what I'm going to do first is to share my screen with you so you can see that I'm already logged into the ROS Development Studio. Let's go and let's share this. So here you have my screen, and this is the ROS project that we are going to use today, the ROS Development Live Class 35. And here, as you can see, there is a button that says Share the ROS project. If you click there, you will get some links. Then you can just copy the link here and send that link to whoever. So you can provide that link to anybody. Anybody that receives that link will get a copy of this. It's like, like Google Docs. So, but this is more complex because it contains simulations and code and notes. And the interesting thing, the more interesting thing is that whoever who receives that will be able to execute the same things in the same conditions. So if you get something running, then that person will also have something running and doesn't have to compile or install GitHub, Docker, or whatever. Just does it automatically. Okay, so I'm going to share that link that you have seen here. So I'm going to share it, but before I have to shorten it. It's just something related to the chat of the Hangout, of the video of YouTube Hangout. So I'm going to I have copied the link here, and I'm pasting right now on the chat. I had to shorten because the chat of the Hangouts live doesn't allow me to put the whole link. It says it's too long, and then it cuts, and then afterwards doesn't work. So anyway, so I have shortened it. So you should have a link this in the chat. Click on the link, and then you will get a copy of this project. Okay, so I'm going to wait a minute for you to click there and see that everything is okay and that is working. Let me know on the chat if you have a problem. See, I say RJ, hello. And what else? It's okay from this guy from Russia. And this is guy from Ukraine. Hello, Roman. Nice. And getting more people here. Brian says, is it possible to get these files offline as well? Like download? Yes, of course. Actually, there is a YouTube video that we have there somewhere where we explain how to download it and then compile in your computer and execute on your computer. The only drawback is that you have to have your computer already with ROS installed and the libraries that this project requires, of course. So this project or any of the other projects, so it doesn't matter. So you can download, and I'm going to show you in a few minutes. So if you are there, let's go and open the ROSjet. Press on this button here, and then it says, yes, so this is about this and that, and let's open it. Okay. Then, yeah, you don't have to say yes. Let's say no, just to start. And then you should get this thing here is the Jupyter Notebook open by default. And then just press on this notebook that is here. Is the only one that is there. So press on the ROS Developers Live Class 35. If you press there, then you will get the notebook. Okay, the notebook is the basic document that explains what we are going to do, what do we have to do in this live class. You can use this afterwards and use it for redoing it or checking some points that were not clear during the class of today. So that's for you. And related to the question of Brian, just going very, very quick before we start, so people has also time. If you go to the IDE here in Tools, IDE, just to answer the question, okay? So you will see here that you have several workspaces. And this workspace is where the simulation is. And my mouse froze for some reason. Let me check the batteries or something. Yes, just a second. Let me see. Yeah. Okay, not yet. Okay, let me see if something wrong. Battery. Okay, here it is. Then the simulation here. This simulation is building on other packages. I'm not going to get into detail, but here you have the simulation that this ROSjet may contain. This workspace contains the notebook with the images and etc. And this Katkin workspace contains the code. In this case, only contains for this ROSjet, only contains the OpenAI ROS that we are going to use, the package. But we are going to create more along this live class. So how do you do? Well, very basic. You come here and then press right-click, download. That's it. You got it. The whole source file. So you don't need here in this Katkin workspace the build and devel. So you can go to the specific package, a specific notebook, whatever you want, simulation or else. And then you can, of course, compile and reproduce in your local computer. The problem is that you have to have the packages and libraries that we are using here by default. So it's a little bit more of work, but you can do it. So let's go. Then, in this class, number 35, we are going to teach different robots the same task and using the same reinforcement learning structure. So we don't have to change from one to another. And for that, we are going to use the OpenAI ROS package that you can check later here on the wiki of ROS. There is a lot more information. So basically, the structure for learning, for reinforcement learning training of robots of this package is this one here. So we have the simulation and we have a connector for Gazebo Simulator. That's already provided by the package. You don't have to do anything. Then next thing is the robot environment. This is the connector to one specific robot. So in this case, is the fetch robot from fetch. So you will need, in order to be able to provide the information from the robot, that means the sensors and actuators from the robot to the reinforcement learning algorithm, you need this robot environment. You need one robot environment for each robot that you want to control on reinforcement learning. That means different robot environments must be created. This package already provides robot environments for some robots that you can check the current list here, but we are building this package, we are building more connectors for other robots. Today, we are going to use the one from the TartarBot and another one from the ROSbot by Usarion here. Okay, so that's the connection from the algorithms to the robot. And now we need the task environment. This is the one that defines the task. And this task environment is the one that defines what do we want the robot to learn. Is the reward, is how to translate the actions into actual actions, and then it communicates with the robot environment and makes the robot move. Then finally, we have the training script that contains the learning algorithm and the loop of any reinforcement learning algorithm. And that's the one that communicates with the task environment. So in this episode here, in this live class, what we are going to do is to keep this, all this, and all this, and just change this one here. That both of those robot environments, the one for the TartarBot and the one from the Usarion, are already provided. So it's only a piece that we have to plug and play. Basically, we have to do some small adjustments. They are going to see, but very, very few. So let's see how it works. Then I see a question from Linda that says, my IDE doesn't show the files, just shows the symbol charging. Doesn't show this. It says strange. And what I would suggest you is that you can just close it here and then open it again. So I don't know. It's strange that you get that. And in case that this persists, then do an F5 here, reload the whole page. And let's see. And then if that still doesn't work, let me know, and we'll give you some other. I'll give you some other solutions. Great. So let's go. So we are going to use the TartarBot 2 and the ROSbot by Usarion, those two robots. Let's go with the first one. Let's start with the TartarBot 2. And well, before I start this, just tell you that this live class, the whole thing, the whole environment, the whole bunch of files, it's provided as a ROSjet. That's what we call a ROSjet. It's a ROS project that is packaged. It's containing all those files that I show you, the code, the simulations, and the notebooks. And that when you share a ROSjet, you can be sure that the person that receives it will work in the same way as it works for you without installing anything. Well, anyway, you have more information there. Let's go and let's start with the TartarBot 2 simulation. And because it's the first one that we are going to train today. Okay, Lagan, he says that he's late, very bad, Lagan. So you have -1 point. No, just joking. Of course, you are welcome. Try to catch up. Then let's go with the TartarBot. First thing that we need is a simulation. Okay, so the simulation is already provided here, and the thing that you have to do is to go here to simulations and then select launch file, because we are going to select a launch file that it's included into the ROSjet that we have provided. So just a second, okay, to clarify. This is the IDE. I'm going to open the IDE. And then here in the simulations workspace, we have put this gym construct simulation that contains some ROSbots and some walls. Okay, so this is the simulation that we are going to launch. But if you go here to simulations, you can either launch from the simulation workspace by selecting the launch file that's here, or you can launch directly any of those simulations of robots. So you can already launch a RobotBot 2, 3D, Summit XL, all those robots, you can already launch by just clicking there. In this case, we are going to use this launch file because we have created a specific environment for the TurtleBot. So let's click here on select launch file. And then here on the menu, select open. Oh, you cannot see there, but if you click here on launch file, you will get 2 launch files. Select main TurtleBot.launch and then press launch. So we should get this simulation that is defined in this launch file here. Okay, that basically is this maze loop brick wall with a TurtleBot on it. Basically, that's it. Okay, so it's running, it's loading, about to show the simulation. And once we have that, now let's create, there it is. Let's create the package that contains the training code that is going to contain the training code for the TurtleBot. So let's go for it. And for that, let's open a shell. In this case here in tools, you get the shells. And let's go to the Catkin workspace source. Remember that if you want to create simulation code, you have to put it inside the simulation workspace. But if you want to create code, ROS code for the robot, for moving the robot, training the robot, making the robot navigate, then it has to go to the Catkin workspace. This is a way of organizing the code that helps afterwards for organizing what should be executed inside the robot or outside in your development machine. So it's a way of separating things. So let's go to the Catkin workspace source. And here, let's create a package. And please create a package with the same name. You have the command here on the notebook. And then just use the same names, because otherwise some configurations later, they will not work. And I'm doing this because otherwise I cannot check of every one of you remotely what is the problem, why it doesn't work. So we have to make it like sure that it's going to work for everyone. Okay, so there we are. And then once we are on the source, here there is an error. So here it should say first here, should say cd robot training, and then create the 2 directories. Okay, so it's just to create the directories that where we are going to put the scripts and configurations and files. And then in this case, here we create mkdir config, a directory that is called config, another one that is called launch, and please add another one that is called scripts. Even if it's not there on the instructions, just add it. So we have 3 of those. You can see that the IDE has created a package here, and that contains the config, launch, and scripts directories. I'm going to check this also, scripts. Okay, great. So for the training of this robot, we are going to use Keras to generate a deep Q neural network. We are not going to see how to do that. Okay, so I'm providing the code already because otherwise we are never going to finish here. This is not the point here today. You can check all the classes that we have done online for that specific purpose. So let's go and let's create a TurtleBot algorithm.py. And this is the code that is going to be on the scripts directory of the package that we have created. So you can go here directly to the IDE, do a right click and say new file. And let's call it like it says there, TurtleBot algorithm.py. Okay, and let's open it. So it opens here on the side. And now let's copy and paste the whole code of this cell, all this code. So what does it do, this code? I'm going to go very, very fast to this. Okay, so first let's copy and save. Here you can select the cell and then do Control-A, Control-C to copy, and then come here and do Control-V to paste. And remember that this dot here, it's indicating that you need to save your changes. In order to save the changes, go to File, Save, or press Ctrl S. Now there is no dot, you see. Okay, so we have the code. This is basically the training algorithm. If you remember here in the structure of the OpenAI, this is what we have done. This is the training script. Okay, so start training and learning algorithm. That's basically what it contains. And what it contains is the deep Q-learning neural network that is made using Keras, different layers and models. And you can check here how it is created, the model. And that's it. And then another thing that it does is to load the parameters for the training. Oops, no, I don't know what I have touched, but it should be Control S. Yeah, here. So all those parameters that are required to create this neural network that is going to run. And then afterwards, we just run the script, the typical run script of reinforcement learning. Then for all the episodes, then do the reset first, then do a step after the number of steps is done, then compute the score, etc., etc. So you get all these typical reinforcement learning. Then yeah, so we have that there, and my mouse is keeping freezing, so I don't know what is happening. Let's see. Okay, so we have that. Now let's create the launch file that is going to start the launching of the learning. Basically, it's a launch file that executes this algorithm, this script, but also that loads previously the config file. The config file is the file that is going to contain the parameters for the learning algorithm. So first, let's create the launch file. And for that, let's go to the launch directory, right-click, new file, and call it star training RTLBot.launch. Okay, let's open it and copy the content of this cell. You can drag and drop or select everything, copy and paste. Remember to save, okay? Remember to save. I'm always getting this error from the students that they say, hey, no, but it's not executing my code. And then it's because the code, even if pasted here, is not saved until you explicitly indicate it. Great. Now we have, so Ricardo, you told me this launch file is launching the script and also the config file. Where is the config file? Here it is. It's a YAML file from ROS. So we are going to use the ROS param server to load the parameters. So for this, we need to create this file on the config directory. Here, go to config directory, right click, and new file. Then use the name turtlebot params.yam and open it. Again, copy, select everything, copy and paste here. And remember to save. Okay, so far so good. So this about the parameters. Again, I'm not going to explain you those because it's not the point. Actually, are the same that we used on the previous class and another class also. So you can check the previous reinforcement learning classes in order to check about the parameters. In any case, you have here some information that it's already there. So here we have divided, the parameters are divided in two things. The first one is the Q-learning parameters. Those are parameters that are related to the reinforcement learning algorithm by itself. And then this is the second part, is about the task. So how do you define the task? So you can tune the task with different parameters in order to get different results. But what is intended is that whenever you have found your task specification, that should not be changed in order to get better results with the reinforcement learning. So, well, I think I'm talking too much about that. Let's continue because otherwise we are not going to finish today. So let's go. And my mouse is still freezing and don't know what is. Let me just change batteries because maybe that is one of the causes. But I already changed it before, but I'm not sure. Okay, so far we have the script that creates this. Yeah, so it's not because frozen again. Okay, so far we have the script, the configuration file, and the launch file, and that's all that we need. How is it possible? But Ricardo, you show us a lot of other information on the OpenAI ROS and a package here. Where is all this already? Okay, yeah, you got it. So this is embedded inside the script, the training algorithm. So if you come here, here to the algorithm, let me put it bigger so you can see better. And also I'm going to make it bigger. Yeah. Okay. So what do we have is that, let me see, where is it? So in this, so here we are initializing the node, and here, let me see, where is it? Yeah, here it is. Here it is, the line. Here, when we create the initialization of the neural network, we are creating the environment of OpenAI. So probably, as you already know, in OpenAI, you have to create an environment. That's the environment. That's the whole structure of OpenAI that will create the reinforcement learning environment, the task environment that will allow you to send commands to the robot and receive the observation, then compute the reward, and finally provide that result here to the neural network. So the neural network here will get this reward that is here. It's provided here, but after every step in the reinforcement learning loop. So how is it possible? Because we are making this GMake environment. Okay, so what is this environment name? This environment name is the parameter that we have included here, environment name. And as you can see, we are generating the Turtlebot 2 maze. That is a task environment as defined here. This is a task environment. And this task environment has been defined already in the OpenAI ROS package. So we don't have to create anything. That's why we are not creating anything else. So where can you find this? Well, if you go to OpenAI ROS here on the source task environments, we have included some examples of task environments. And then here on Turtlebot 2, you can see that there is this Turtlebot 2 maze. Okay, so is this Turtlebot 2 maze? If you open it, you will see the definition of this environment. So the system knows how to instantiate this, and by instantiating this is creating the Turtlebot 2 maze environment. That is the task environment. Actually, this is the task environment, and then afterwards, this environment, it inherits from the Turtlebot 2 environment. This is the robot environment for the Turtlebot, as specified here in the robot environment here. So by coming here and creating this environment, actually it's not there, it's here. By doing the GMake, the whole sequence of task environment, robot environment, gazebo environment connection into the simulation is generated. So then the script is able to communicate there which actions has selected, and it's able to receive the results, the reward, and the state, the new state. Okay, so that's not the goal again, but just wanted to show you a little bit because we need to understand that in order to change afterwards for the other robot. Okay, well, so what are we going to do? So if we have everything, what do we want to see? Everybody wants to see how the robot starts learning. Okay, so let's do it. What are we waiting for? So for that, we need to go to and do the source of this demo, because of some definitions made by the OpenAI ROS package. So let's go to this Catkin workspace here, and actually you can put CD Catkin workspace, yeah, ROS CD. Yeah, and then here you do the source as is indicated on the notebook, devel/setup.bash. Now it's done. We don't have to compile anything in this case because everything else has been already compiled. So we only need to launch it. So let's do a cross launch of robot training and start training. Turtlebot launch. Okay, so here we go. And if everything has been copied properly, then in some seconds, this has to start moving around, and there it goes. So now it is learning, executing the first episode, trying to learn. And when it collides, it has collided. Then it's going to restart the position and start again a new episode of the reinforcement learning. Okay, so that's it. So at the beginning, it's very random, but if you leave the system for several generations, several episodes, then you will see that it's starting to improve. At the end, it can move around. Okay, very good point by Danny Dask that says, remember to give execute permissions to the script. That's very good point. Then I wanted to avoid that, Danny, by putting the script inside the scripts directory. If you put the script inside the scripts directory, you don't need to provide that permissions execution. Okay, so let's also open this graphic. If you go here to Tools and go to OpenAI Reward Chart, so you can open it. And it's going to start putting here the rewards that it has obtained. So we are working on this, on improving it. So we only got this from the 7th execution here on the 8th episode. And it's going to continue as we talk. And we are going to see a graphic like the one that you can see here in the notebook in a few seconds, in a few minutes. So there is a question that I saved on the chat that says, does Jim Wrappers Monitor save the actions to the JSON file? Does it also record Gazebo video or only the JSON TXT? Only the JSON TXT at present. At present, yeah. So it's going to save it in a data directory around here. I don't remember exactly, but it's going to save it here. Yeah, here in the data. So here you are going to get it here, but not recording the video. Then that's a good suggestion anyway. So there it goes, the robot, and it's kind of learning how to do it. So we need to get more iterations, more episodes in order to get the robot moving around. So maybe we can leave it a little bit and see if it does something more interesting, other than going to the other side and crash. Any question? Any other question? No? Okay, let's leave it like that. So it's doing some training, and then let's try to work the most without disturbing the Turtlebot, so maybe we can see how it actually learns to move around. So, okay, so far so good. So I hope that you have understood how this robot, the Turtlebot, so we are creating, by using the OpenAI ROS, we are creating a complete training environment for it to solve. And as you can see, the only things that we have had to create is the learning algorithm, and then indicate, hey, please, I want to learn in this task environment. And that's it, because this is provided, the task environment and the robot environment, and the simulation has been provided, everything by the OpenAI ROS. Well, actually, the simulation is not provided by the OpenAI ROS, but the task environment and robot environment, Gazebo environment, yes. So we only had to do this for that specific robot. Okay. Now we are going to use the ROSbot by a company called Usarion. I think that one of the people from Usarion is here at the live class. So hello, people, Dominique, Philippe, and Huber. I think it's here. So hello, if you are there. And we are going to see what do we have to change in order to do the same training on the same environment, but using a different robot. You're going to see that it's quite small. Still, some questions there. After by Saif, he says, after training, what about if we start from different initial point? Does it still able to navigate? Yes, I think yes. But but I'm not sure completely, because I don't know if the solution that is creating this robot is going to be enough. In theory, yes. In theory, for different reasons. Because I mean, this point has nothing special, but we should analyze. The purpose is that this task that we are doing here is just a test. It's just an example to make you understand the whole process, the whole pipe of training, and making everything work. So you have here something that works, and from that point you can make it more complex as much as you want. For example, in order to make it more universal, the solution, this maze should contain different types of turns and in different directions, because otherwise the robot is only learning to turn to the left. So those are things that you should try to take into account in case that you want to make an autonomous really navigate in any environment. Then Cheryl has another question. She says, could you explain briefly how the learning algorithm works? You mentioned it has a neural network. Yes, so it's a deep Q neural network that is being created by using Keras, a sequential model. And basically, it's a typical learning of any neural network. So you get the prediction of what the output should be based on the current state of the algorithm, and then the prediction of the state, and then you get the actual state that the robot is getting after the action. And then so you change your prediction on that, and based on that, you change the weights of the neural network. And you repeat this among all the steps, then you will get finally that the neural network is tuned to that state to predict the correct state. And because some states provide more reward than others, then the neural network will select the actions that provide the most reward. That is, the ones that make the robot move forward and do not collide. Okay, so Lagam Kapoor says, Cheryl, there is not much time to explain this algorithm. Cheryl, okay, yeah, well, some explanation. Okay, let's continue now. In this case, let's use the Usarion robot. And wait, here the mouse. Okay. Okay, so that's the simulation that we are going to launch here about this robot. So let's not launch it yet, because we see that the robot is still moving. So before we start with the simulation, with the training for that robot, we'll launch it. So we can keep the robot training. As you can see, it's getting better and better, as you can see. And then, yeah, so sorry, Cheryl says, okay, thanks, sorry, no sorries, of course. You can ask any questions. I will try to do my best to answer them. Then whatever it is that we have to change first the robot environment for Usarion's ROSbot. And as I mentioned here, we have in the source the OpenAI ROS package. Here we have the robot environments that we are using. Damn it. I'm getting stuck by this mouse thing. I promise on the next live class we are going to have better. And it's still not working. Yeah. Okay, so here on the robot environment, we have the different robot environments for different robots already provided. For Sawyer, for Shadow Robot, Summit XL, Tartabot here. And the one that we are looking is for the Usarion environment. Okay, yeah, I know the robot, the environment should be called ROSbot. And we put this name, maybe in the future versions will change. So actually, that's the environment that we should use for that robot, for training that robot. Now, what we are using is the Tartabot 2 environment. Okay. So this is the one that we are going to use, okay? But how do we change that? Okay, in order to learn how to change that, we have to go all the way back from here, starting from here, and see where this has been instantiated. Okay, so what we are going to do is to create another task environment that is going to start, is going to be a copy of the one from the Tartabot 2 maze. So let's go to, you can do it directly here, okay? So in another way, in another day, you can do it better in another situation, in another, in a better organization. But for today, it's okay if we do it here. So then it's, what we are going to do is to copy that one. So let's go to the task environment here in Usarion. And then here we have another actually, I put the maze already. Yeah, I put it and I forgot to delete it when I was testing. So yeah, so here we have already the maze. And so what I would suggest is that you don't look at this. Okay, so this you can leave it there, but let's not look at it, because otherwise you will have already the solution. Let me change the name, because otherwise it's going to conflict. Let's put Usarion maze underscore. Let's change the name by right click, maze, the good one. So you can check later in case that there is some problem. But now let's do the actual work. Okay, so what we are going to do is to go to the Tartabot maze here, then duplicate that one, and then just change where it says Tartabot 2, let's change for Usarion. So let's do a Control C, right click, and then duplicate. Then we have this duplication, and let's change the name here to Usarion maze. Instead of Tartabot, let's say Usarion maze. And of course, this has to be put into the Usarion task environment directory. So you move it there in Usarion. Okay, now we have this Usarion maze here for Usarion, but it's not correct. So let's open it. If we open it, we have here that there are some things that are not correct. First, the ID is not correct because we are not going to call Tartabot 2 maze. We are going to call it Usarion maze. So let's go and change that. This is an identification only, but this is the name that we have to go afterwards to the start training. Here, Tartabot algorithm. And here is the one that we are going to change. Instead of Tartabot maze, we are going to say, hey, please create an instance of this task. Okay, that's very at the beginning, only this. But the actual work is going to be by indicating here which one is the entry point. In the entry point, you are indicating first. Yeah, I'm having problems with my mouse and I cannot move. I cannot move. Not yet. And yeah, the weather is fine here. Yeah, How about there? Okay, yeah, moving. Okay, so first thing is that the task environment talked about too. So if we go here, you can see that in the task environments, let me close this. In the task environments, we have the Turtlebot 2 and then the Turtlebot 2 maze. So here we have to change for the Usarion maze. So let's go. Usarion, instead of creating an instantiation of the Turtlebot 2 maze, let's create an instance of the Usarion maze. And then here we have to indicate the actual class inside the Usarion maze that we have to execute. For that, let's open this. Yeah, so yes, the class is here, is this one. That's the entry point. And we need to change this because otherwise it makes no sense. Well, actually it's not needed, but it's just to make it more clear. So let's change this name here. Let's say, hey, the class that you have to execute is the Usarion maze environment, okay? And that should be the name that we should put here to the class, to the actual class. This is just a name, okay? It's not super important, but it's just to make it more clear for you. Then this maze environment has to inherit from the actual robot environment. So here is where we are indicating this environment that we have to use. So in this case, we have to use the environment for the robot Usarion ROSbot that is called Usarion environment. That is here. It's already provided by OpenAI. So we have to change also here Usarion environment. So we are indicating this Python file. And then inside there, which one is the class that contains the actual implementation. So let's go there. Let's open it. And the class is called Usarion environment. So that is the class that we have to put here in the Usarion maze task environment. And yeah, basically that's it. We need to do a couple of more changes, but basically is that. So we have done is, hey, please register this with a different name. And let me tell you that the entry point, the class that you have to instantiate for the maze for Usarion is this one. Okay, but this one from which one inherits? Well, it inherits from the Usarion robot environment. So that's it. Then other things that we have here. Okay, so other things is that the parameters. So the parameters, instead of calling them Turtlebot2, we can call it ROSbot. Okay, so we can change all that for ROSbot. You don't need to do it now, okay? Because we are going to copy paste the whole project. And then let me check. So you have several parameters here that you should change also. Okay, let me check if we have another thing here. And that's it. That's it. Just where it says Turtlebot2, you can say ROSbot by Usarion. And that's it. Because why? Because the Usarion robot provides the same interface. It provides command bells. It provides lasers. So the training algorithm already is able to get that information because it's already able to get that information from the Turtlebot. So basically, that's it. You don't have to do more changes in this case. So instead of changing all the parameters there, let's do one thing. Let's come here, and I have included here the whole code, the correct code. It's here with as you can see, the parameters change. So let's copy and paste. So select everything here, copy, and then come here, select everything and replace by the new code, by the code of here. And by doing this, you will have all the changes that I have done manually, as well as the changes for the parameters. And as you can see, it's as simple as that. Now, let's continue because we are about to make it. Let's continue. By the way, the Turtlebot is already able to move around. As you can see, it has this reach very fast how to move around. Okay, so anyway, we can stop that, but let's continue because we are about to finish. We are almost there. Then what do we have to do? Is to create the ROSbot algorithm training a script. For that, let's go here again to our package, robot training. Let's go to the scripts directory and create a new file. In this file, let's call it like it says here on the notebook. It's called ROSbot _ algorithm.py. And if you open it, you should put the content here. And I'm going to explain you a couple of things here. Okay, so select here everything, Control A, Control C, and then paste it here. Okay, so here, this is exact same algorithm that we had for the Turtlebot. It's the same if you compare. The only things that you have here different, let me show you, are that, instead here is for the name of the wrapper for the data that is generating the training algorithm. That's just a name of the file. And then here you can see that everything is doing the same thing because the parameter environment name is not taken into account here. So it's not defined there. It's just defined here in the main script. So now in here, instead of saying environment name Turtlebot2 maze, let's say the Usarion maze, that's the name of the task that we have defined here in the Usarion maze. By the way, remember to save, okay? Remember I have the dot there. So I have to save, Control S, all changes save. And my mouse frozen again. I think that we should change the name of this live class for the one where the mouse freezes. And okay, there it is. Okay, so here in the ROSbot algorithm, we have changed this name and we have put the name here of this ID, the one that we have created here. So the task environment that is going to be generated is going to be the one for the Usarion maze. So it's going to take into account that different robot. And it's getting worse and worse, I think. Yeah. Okay, come on, almost there. Come on, move. Okay, yeah, so basically that's it. Also, the parameters that they have changed the prefix of the parameter for ROSbot, but basically that's it. Okay, yeah, you need to know the name of the ROS node also. I have changed it just to make it clear, but that's it. So I'm only telling to the algorithm, hey, please execute this. And if you want to make it more universal, you can even get rid of this in both cases. So you will not have to change even this, the parameters. Yeah, we didn't think about that before. Okay, so that's it. Let's keep on. Remember to save this ROSbot algorithm. And let's continue with the config file and the launch file. The config file is here. Is the same thing. It's just change the namespace from Turtlebot to ROSbot. Okay, so it's in order to get it separated. So let's go to the robot training, go to config, new file, control, right click, new file. Let's say ROSbot params.yam. Open it, copy here the content, Control C and Control V, and save it. Remember to save it. We are almost there. And there is a here that says, Danny does, that says, my Turtlebot is not the smartest. It only can complete half lap loops. Yeah, but that's not because it's stupid. It's because the algorithm is stopping after a number of movements. So it's only able to reach this point here. So it's going to happen the same to me. You see, it starts again. So don't worry. You are doing great, Danny. Great. So you have the parameters. Let's create the launch file, and we are done. We can launch it. And the question, my mouse frozen. RJ, it's indicating, do the robots have similar constructions? Yes, that's it. They do have similar, not the same, but similar. So both have a laser for detecting obstacles. Both have a common bell topic for getting commands for moving the wheels. And that's it. So that's what it's that's what it needs, this task. And it looks like it's completely frozen. Yes, completely frozen now. Okay, so here's having some trouble. Yes, here it goes. The launch file, and we are done. You see, we are almost there. But I cannot reach the point. I can see the end line, but I cannot reach it. So I'm playing here with the batteries, but it doesn't work. RJ is indicating that he has another thing. So what is this? This is strange. So he says, if I would use like a full-fledged robot, do I need to manipulate the environment? Yes, definitely yes, because it's completely the observations that is providing is different, unless you manage to make unless you manage to create a common bell that makes the robot makes a step. So that's possible. Yeah, we did it. And it's with some human-sized humanoid robot. Okay, let's go. Let's finish. Launch. Control. Right-click. New file. Start training. ROSbot.launch. Open it and copy here. Basically, it's just saying, hey, instead of this config file, do this other one. Instead of this training algorithm, do this other one. And that's it. So now let's launch it. Let's close this one. You can do here Control-C. Remember that you have generated here the training file. So I'm going to close it. Now, first, we need to launch the simulation. So go to Simulations, select Launch File, and here select the one from ROSbot now. So now let's launch it and get the ROSbot there. And we are there. We are there. Come on. It's launching the simulation. And here we can start preparing to launch. So do the ROS launch in the shell. The package is robot training. Robot training, and then start training ROSbot. Launch. And there we have the ROSbot simulation here. Okay, so ROSbot algorithm. Okay, so there is an error. Sorry, I said maybe a name. ROSbot algorithm.py can locate it. ROSbot algorithm. Some mistake. I cannot find it. I cannot see it. Looks like it's correct. Let me check. Let me open. Is this safe? Everything? Yes, it's on the proper robot training. It's called robot training. Let me see. Anybody, any clue? Help me to find it faster. The problem, ROSbot algorithm. It's correct. So I don't understand why is in package robot training, ROS CD, robot training. Let's see if it is there. See, sometimes it's some misspelling, so it's better if you copy paste because you will be sure that you are going to the one that the message is indicated. Then there, let's go to scripts, and then say, okay. Oh, okay. So why it didn't? Okay, yeah, it's the problem of the execution permissions. Okay, so yeah, I know how to solve it, but I don't understand why did it appear now. Okay, anyway, very simple way to solve it. chmod +x ROSbot algorithm.py. Okay, so we are providing now the permissions, but it should have already the execution permissions. That's why this is strange. Okay. Danny says he gave us the solution. Yes, that's right. Previously, yes. Yes, that's right, Danny. Very good. Okay, let's launch it. Let's make this robot move and start learning. So let's go. There it goes. And yeah, come on, ROSbot, you can do it. Yes. And there it goes. And it starts training. Great, cool. Well, as you can see, so there has been some work to do, but it was very, very small and very well localized at the beginning of these scripts. And basically, it's just to indicate, please instantiate a different class. Basically, that was that. So you have seen how easy it is to train for different robots. Yeah, one of the things that make this easy is that the task environment for the Turtlebot maze was already provided, and that the robot environments for the Turtlebot and the ROSbot both were provided by the OpenAI ROS. In case that you want to use this structure with your own ROS robot that doesn't have yet an OpenAI robot environment, you can do it. It's very simple. We have included here in the OpenAI package source some templates. Let me show you here. Where is it? Where are the templates? Task environments. Here, the templates here. And you can see a template for robot environment and another one for a training environment. I mean, it's a task. So have a look at them. And also you have many, many other examples for other robots. So you can take them as examples. And then that's it by now. So before we go to some questions, in case you have it yet, let me remind you, please give us a like on the video. Give us a thumbs up in the video. There is beneath, there is the thumbs up. Please do that if you like the class, because we work very hard for that. And we are very proud of that. And also I would recommend you that you subscribe to our channel, if not yet, because we are providing a new ROS video every day. So you can be notified about the title, the subject every day on your email and see if that interests you. And also we have an academy online that is called Robot Ignite Academy, where we teach about OpenAI. We have a deeper course on OpenAI with ROS using the baselines of OpenAI and making the robots make a lot more complex things. So check our academy and see if it's so if you find a course. We teach also from basics, ROS basics with C++, deep learning, autonomous cars, drones, etc. And finally, I would recommend you that you listen our podcast that is called the ROS Developers Podcast. And we publish a new episode every week, every Monday. And it's quite interesting because we are interviewing people that are experts on the on ROS, on development, and they explain us how they do it, how do they program, which packages we can use. They provided also with links to simulations, to source code that you can use in your own developments. And that's all from my side. So if you have any question there, I'll be there for you. So Hubert says like this. Yes, thank you very much, Hubert. If you can also put it on the YouTube, you know that YouTube has a feature that you can press there and we get a thumbs up. That really appreciate it also. Any questions? I'll be here for a couple of minutes more. And otherwise, so Lagan says thanks. Thank you, Lagan. Thank you very much. RJ says, do you have some tutorials how to code a new environment for a new robot on YouTube or Robot Ignite Academy? Not yet. Not yet. Remember that this package has been released in September, late August, September. But we plan to do that because that's very important. It's a very important subject for people so they can use it in their own environments. You can start, if you're interested on that, please start with the templates. And if you have any question, you can send that to me. Any other Any other question, guys? So if there are no more questions, I'm going to stop here for today. Remember that we have another live class next week, and it's going to be about so the models that we generate here by training. So it's going to be again on the same subject. So once you get that model generated, how do you use it on your robot? Because here is learning, but then afterwards I want to put it into the robot. So how do we download this learn the neural network, and how we use it on the robot? So we'll see how to do that. Okay. So thank you very much, guys. Thank you, RJ, Saif, Cheryl. Thank you very much, all of you. Danny, everything worth. Thanks for these classes. My pleasure, Danny. And see you all people around the world. Okay. So remember, keep pushing your ROS learning. Cheers.